All right. Hello, my peoples. This is lesson 3-9 in the Tennessee Revealed Geometry, proving lines parallel. Okay. First off, you need to know that parallel lines are in the same plane. They are coplanar. Parallel lines have the same slope. All right. So let's get on into it. All right. So you guys, I'm on page 221. Looks like we've got to learn some things that you got to go through. All right, so let's talk about these little symbols right here. Those little symbols right there, you're going to see on the ACT. It means that these lines A and B are parallel to one another. And when the lines are parallel, you've got all kinds of angles being equal to each other. And I love that they color coded this. I do this in my classroom as well. In fact, I'll give students two different colors, whatever two colors they want, and all of your little acute angles are equal. So this 8, 2, 6, and 4. I'll have them marked the same color, and the obtuse 1, 7, 3, and 5 are all equal to each other. And don't forget, these linear pair right there, they're supplementary. That have to be 180. So there's your little shortcut to finding them. All right, so one more time. These are your parallel symbols. This is a point on the line. And so we are looking at probably crossing over, see, with the transversal. Yep, here they go. Okay, so you got transversal. Now, if these angles are congruent, then the lines are parallel. That's what we call a converse, because the original is if the lines are parallel, then your alternate exterior angles are equal. Your alternate interior angles are equal, congruent. And let's see, your consecutive interior angles will be supplementary. That means they add up to be 180, and there it is right there. All right, so it looks like you go online and there's something there for you to do. I'm just going to go ahead and get into it like I always do. Example number 1 says, use the given information to determine which lines, if any, are parallel and state the postulant or theorem that justifies the answer. All right, so angle 2 and angle 8. So you visual people, there's angle 2 and angle 8. And the first thing I ask my students is there a line they're both on? Because that's going to be your transversal. 2 is at the corner of A and L. 8 is at the corner of B and L. And since I said L twice, L is your transversal. So they're both on L. Now, are they both on the same side of L or on they different sides of L? Well, 2 is above the line L. 8 is below the line L. That automatically makes them alternate. So they're alternate something. They're alternate something. They're either alternate interior or alternate exterior. Well, here's how you tell. If L is the transversal, and by definition, a transversal is a line that crosses two or more lines, it crosses the other two that I said, A and B. Those are the two lines that L crosses. Now, the question is 2 and 8, angle 2 and angle 8, between A and B or not between A and B? Well, they're between them, which makes them interior. So these are alternate interior angles. So angle 2 and angle 8 are alternate interior of lines A and B, because angle 2 is congruent to angle 8. A is parallel to B by the alternate interior angles theorem, or converse of the alternate interior angles theorem. Three and 7. Well, all right, well, there's 3. There's 7. All right, first off, is there a line they're both on? Yeah. 3 is at the corner of A and L. 11 is at the corner of A and M. What did I say both times? I said A. A is your transversal. Now, are they on the same side of A, or are they on different sides of A? Well, 3 is on the right of the line A, and 11 is also on the right of line A. All right, so that tells me that two things are either happening. They are either same side interior, or they're corresponding. Excuse me, they're corresponding. Well, I tell my students that the corresponding angles are the black sheep of the family. They're neither interior or exterior because it's both. The two lines that A crosses is line L and line M. Well, 3 is between L and M, but 11 is not between them. 3 is interior, 11 is exterior. That makes them corresponding. Of lines L and M, because 3 is congruent to 11, L and M are parallel by Well, corresponding angles. All right, 12 and 14. Okay, here's 12. There's 14. Same thing I always ask. Is there a line they're both on? And absolutely, they're both on M. 12 is at the corner of A and M. 14 is at the corner of B and M. They are both on M. That makes M the transversal. Now, are they on the same side of M, or are they on different sides of M? Well, 12 is below line M. 14 is above line M. That makes them alternate angles. Now, the question is, are they alternate interior or alternate exterior? Because those are your two choices after you realize they're alternate angles. M crosses line A and B. So are these two between A and B or not between A and B? And since they're not between A and B, they're exterior angles. So these are alternate exterior. Okie dokie. Moving on. Got a check down here. All right, it says, use the given information to determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. Okay, no problem. Angle 1 and angle 15. All right, here's angle 1. There's angle 15. Same thing I always ask. Is there a line they're both on? No. Angle 1 is on L and N. Down here, 15 is on M and K. They don't even have a transversal. So, yeah, it looks like it's not possible to determine if they're parallel or not. They don't have a transversal, you guys? I'm not really sure. Maybe, maybe not. I don't know. So, no, I'm not going to say. All right, let's see what we're going on here. Angle 3 plus angle 10 is 180. Well, here's angle 3. There's angle 10. Do they add up to be 180? I guess is the question. Well, is there a line they're both on? Yeah, they're both on L. They are on the same side of L, which means our only choices for same side are consecutive interior. And yeah, consecutive interior angles are supplementary. Corresponding is our other choice. But remember, corresponding angles are the black sheep of the family. You have to have an innie and an outie. And for our problem, 10 and 3, they are both between N and K lines. So these are consecutive interior angles. Now, I'm not sure what it wants here. For Windows, in for Mac, Math Editor button. Okay. So I'm not sure what it wants me to put in the equation editor because I don't know what they are. I don't know what their measures are. But yeah, I would say that L is my transversal. It crosses N and K. And since they're consecutive interior, I'd say what N is parallel to K. All right, so let's see. N. I need a skinny 11 for parallel. Skinny 11, there it is. And K. So look under the geometry tab. There we go. N and K parallel, consecutive interior. Okay, here we go. 3 and 5. There's 3. There's 5. They're both on N because 3 is at the corner of L and N, and 5 is at the corner of M and N. So they're both on N. That's your transversal. All right, N crosses L and M. They are between, and they're on different sides of N. So these are alternate interior. So I'm looking for alternate interior. Uh-oh, look at this. I got 2 alternate interiors. They're trying to trick me. They're trying to trick me. One more time. They are on N, because it's 3 and 5, but it's passing L and M. So L and M have to be the ones that are alternate interior. They're trying to trick me. Well, you can't get me this time. I'm moving on. All right, example number 2. All right, so I see a little box here. That means 90 degrees, and the word perpendicular means the same thing. All right, so I've got 2 things. They're both on D. It crosses E and F, so D is my transversal. All right, you'll know that D is the perpendicular to line E. For lines E and F to be parallel, line F must also be perpendicular to D. Well, yeah, that makes sense. 90 plus 90 is 180. If line F is perpendicular to D, then 4y plus 10 equals 90. Solve for y. All right, so 90 equals, that's the definition of perpendicular. Subtract 10 to the other side. So now I have minus 10 would be 80 equals. And divide by 4. So 80 divided by 4 is 20. 20 equals, because 8 divided by 4 is 2. And put in the 0. All right, so it looks like that is it. All right, here we go. Got to check. All right. Looking at these two angles right here, they're both on K. That's your transversal. They're on the same side of K. However, the 2x plus 1 is an any, because it's between M and N. And the 6x minus 3 is an outie, because it's not between them. All right, black sheep of the family, you guys. These are your corresponding angles. Corresponding angles are equal to each other if the lines are parallel. So you're going to need to set those two things equal. Oh my goodness, give me a place to do it. So put 6x minus 3 equals 2x plus 1. Solve it. So let's see, 6x minus 2x is 4x. Add 3 to the other side to get a 4. 4x equals 4. Looks like x equals 1. Identify the postulate corresponding angle. Which will give me some room. All right, let's see what's going on here. Find angle LMN. So I'm looking for this angle right there that's labeled 4x plus 6. All right, so these are your parallel lines A and B. That makes line C your transversal. Okay, well, I see a bunch of X's. But remember, your color coding. This is an acute angle. This is an acute angle. This is an acute angle. And the 4x plus 6 is an acute angle. Those are your ones that are equal to each other. This angle, 2x plus 152.4, is obtuse. These are not equal to each other. These two angles are the linear pair. They add up to be 180. All right, so there's multiple choice here. All right, I'm going to put 9x minus 12 equal to 4x plus 6. So I'm going to subtract 4x to the other side. 9 minus 4 being x's is 5. Add the 12 to the 6. And that gives me 18. And I'm going to take 18 and divide by the 5. Grabbing my calculator. So I get 3.6. Now, yes, that is x. X is 3.6. So don't pick this one. I don't care if you really want to, because 3.6 came up on the calculator. This is geometry. That is not what they asked for. They want the measure of angle LMN. LMN. So I want you to take that 3.6 and plug and chug. 4 times 3.6 and then add 6. Here's your answer, 20.4. So if you put 3.6, you just missed it. Oh, y'all, ACT loves doing that to y'all. Make sure you look back and see what they asked us to find. All right, there's another example online if you want to grab that and look at it. All right, example number 3. To move in a straight line with maximum efficiency, oars should be parallel. I guess they're talking about these two black lines and these two red lines. Refer to the photo at the right. It is possible to prove that any of the oars are parallel. Or is it? My bad. Justify your answer. Okay. Well, all right. First off, I see this 124 is an obtuse angle. And its corresponding angle, if the lines are parallel, are also 124. Which means these two angles, the 124 that corresponds to 124 and the one adjacent to it, 50, should add up to be 180 because they're the linear pair. So the question is do they add up to be 180? Well, let's take 180 and subtract 50. And 180 minus 50 is 130. And since that is not 124 degrees, yeah, the lines are not parallel. So something with these two rowers is off. The measure is 130 degrees, which is the, let's see, how do they want me to word this? The angle measuring 130 is the what angle to the other angle? Well, is the supplementary or adjacent angle to supplementary angle to the 50-degree angle? So is the supplementary to the 50-degree angle, and because the corresponding angles are not congruent, then the lines are not parallel. I'm not sure if that's exactly what they wanted, but that's what makes sense to me. Therefore, it is not possible that the oars are parallel. So these two guys are doing a bad job. Get it together, fellas. All right, let's move on. All right, we got an antenna. Oh, interesting. All right. Is it possible to prove that the support poles of the antenna complex are parallel? Okay, well, I'm looking at this, you guys. If these are parallel, which they don't even look parallel, these two angles being on the same side of the transversal and between the two lines that is in consecutive interior, they should add up to be 180. So the question is 120 plus 54 180? Yeah, no, that's going to be 174. So they no consecutive interiors are not supplementary. So here we go, not parallel. All right, looks like I got a couple of things that are online. You need some extra examples. On to the practice. All right, you guys, this is the point where you go and you ask your teacher your questions or shoot me a question. I'll be happy to help. All right, you guys, have a great one.